Hello, today our team consisting of myself, Abhishek, Jeong, and Tanmay will present our mobile implementation of ChatGPT. Our application is a mobile application that enhances user interaction with ChatGPT through voice to text and text to speech technologies. Our project expands ChatGPT's scope, fostering inclusivity with natural spoken language communication, making it user friendly and available anytime and anywhere. Now, let us move on to related works. There are three key technologies which are speech recognition or speech to text, text to speech, and mobile conversational AI. First, we went through exploring speech recognition, a technology, thanks to papers from Xudong Huang and Hinton. This helped us go from basic voice commands to understanding speech in a natural way in real time. Now, let's talk about speech to text systems. Using Tachotron and WaveNet, we moved from robotic voices to ones that sound more human. This change makes using our technology more enjoyable and makes it feel more like talking to a person. Our discussion won't be complete without looking at mobile conversational AI, how we talk to our phones, inspired by Siri, Google Assistant, and Alexa. We are adding ChatGPT to make conversations on mobile devices smooth and natural.
Okay, so now as Abhishek mentioned, we will now look at ChatGPT. OpenAI's ChatGPT has been a significant focus of recent research due to its amazing advancement in natural language understanding and its generalization capabilities. And studies have actually looked at using ChatGPT for a lot of different educational tools and other applications. The thing that we are especially interested in is a voice bot. So in our voice bot, we leverage the latest advancements in speech to text and text to speech and conversational AI, and then combine them with a mobile framework to help us in our day to day life. Okay, so now we are going to take an overview of the implementation in our mobile app. Our mobile app uses Flutter Development Kit as our primary base. So we have a few key features. We have an API key verification. The application conducts a thorough check for the presence of a valid API during initialization. And in instances where a key is not detected, users are prompted to input the necessary credentials. Then we have dual screen, that is basically a home screen and a chat page. In a home screen, user gains access to a comprehensive log of their previous conversation with the ChatGPT voice bot, thus providing a historical perspective of the interactions. And there's a chat page, which is an interactive interface which empowers users to prompt the applications for responses using both text and voice inputs. Along with that, we have a Hive model implementation. The application employs a Hive model to systematically store messages, including metadata such as messager's author. Is it a user or is it the AI? And the timestamp of creation. And also, we store all these chats on the user side, not on server side, thus providing thus providing privacy and security towards sensitive data. Now let's talk about user interface dynamics. The user interface actively responds to prompts provided by the user, managing user AI interactions with intelligence and efficiency. The application gracefully handles user AI exchanges, preventing the user from issuing new prompts while awaiting a reply from ChatGPT. Now, let's take a look at the utilization of the speech to text library. So, we have employed the speech to text library from pub.dev into our pipeline. Our application harnesses the capabilities of the library, which is very well established in the Flutter community, and it is instrumental in facilitating both speech to text conversion and enabling the application to reorganize and process spoken language. The speech to text library listens to the prompts from the user and uses speech to text recognition to convert the captured text and speech. Now, we also would look at the text to speech capabilities that we have integrated. Again, we have used the standard text to speech library available on pub.dev to do our particular task. We have provided multilingual support on which Abhishek would elaborate.
Now we will share about web scraping integration in our application. Our project initially embarked on an ambitious task, which is scraping Purdue University's official website to extract meaningful data. For example, if we ask what kind of majors does the College of Science have, then we expected to get the answer there are computer science, statistics, and mathematics, and etc. To accomplish this, we leverage Apify's robust web scraping capabilities. This required us to first set up key software packages and configure API keys to ensure smooth operation. A crucial part of our process involved utilizing PyTorch, a powerful tool to help the GPU acceleration for efficient data processing. This step was pivotal in optimizing our data extraction and handling. Our approach was to target specific URLs for scrapping. For instance, when we focused on the CS536 course website, the system officially created an optimized vector store. This allowed us to perform complex queries on the extracted data. The results were quite interesting. When applied to the CS536 webpage, our method had excellent outcomes demonstrating a potential of targeted web scraping. When we asked who is the professor for CS536 after putting in the link of the 536 website, it successfully answered Chani Peng. However, when we attempt the same thing with the official Purdue University site, the results were less impressive. The highlighted challenges and the varying effectiveness of the web scraping across different types of the website. In that reason, even though it was a powerful tool, the effectiveness can vary greatly depending on the complexity and the structure of the target website. Let's dive deeper into the challenges we faced with our web scraping part in our application, specifically with the Purdue University official website. Our initial attempts to scrap the entire website revealed a significant issue with which that the website was too large. Processing such a vast amount of data was not only challenging but also time consuming. It took more than 30 minutes to scrap all of the information. This raised a serious efficiency concern for our project. Who will use our application if it takes more than 30 minutes with a single question? Therefore, we thought directly querying ChatGPT itself instead of using our implementation. While some queries in ChatGPT utilized Bing for direct link searches, other involved ChatGPT scrapping relevant data from the website itself, which we were targeting. This approach drastically improved our response time. We saw a decrease from an initial 210 seconds to less than 3 seconds per query, enhancing efficiency by more than 70 times. In that reason, we decided not to use this function in our model, and this were our limitation.
We set out to achieve a goal of developing a mobile app which helped the users get answers to their questions in an accessible form. We faced several challenges like slow response times and had to make adjustments to our initial ideas. But ultimately, we were able to accomplish our goal of developing a mobile app that answers queries in an attainable, efficient, and interactive manner.
So for our future works, we were gonna make some improvements, such as decreasing the time of the response and then increasing the efficiency and support additional language, perhaps even American Sign Language. We were gonna add more features, such as changing voice of the AI responder or change the speed of the voice that people could understand more clearly. Ultimately, we want to make this application that everyone could use this, even though no matter what their phone they uses, such as iPhone, Android, or other BlackBerry phones. So thank you for our thank you so much.
Thank you. 감사합니다.
धन्यवाद.
Thank you.
아리가또
아리가또
고자이마스.
고자이마스.